Hello guys, welcome back to my channel and let's do a sweet integral. Let's get started. So we have our integral I defined as the integral from 0 to 1 of natural log of x whole thing squared divided by 1 plus x squared dx. Now go ahead, pause the video, try some elementary integration techniques or maybe some other methods too if you want. And after you're convinced that this can't be done with any other method, then you can again resume watching the video. Okay, so I hope you've done that. And now the great trick here is noticing that x is on the interval 0 to 1. So what's so great about this interval? Well, that's because notice the denominators of the form 1 over 1 plus x squared, which can be written as 1 over 1 minus x squared. And if you remember now, the formula for an infinite geometric series. So if you had this geometric series from say r equals 1 to infinity of a times r, let's call the index n, so a times r to the n minus 1. This, if absolute value of r was less than 1, then this infinite geometric series converged and the formula for the sum was a over 1 minus r. So now notice that this is of this form, but is our common ratio here, our common ratio is negative x squared. Is it less than 1? Notice that x belongs to 0, 1, so it's this inequality is set like this. Since we are only concerned with the absolute value, we can ignore the negative sign associated with the x squared. And definitely x squared is again going to be between is also going to be on this interval of 0 to 1. So our geometric series converges, and this formula can be applied because our common ratio x squared, actually negative x squared, is within the radius of convergence. So if you've done infinite series and sequences, you might know what I'm talking about when I say the radius of convergence. So since we are inside our radius of convergence, we can use this. This can be applied. So instead of writing this as a, because this is now in the form of a over 1 minus r, we can just write it as this infinite geometric series. Let's do that. So now we can write everything as integral from 0 to 1 of natural log of x squared, and now we have the sum from k equals 1 to infinity of a, in our case, is just 1. So 1 times r is negative x squared to the k minus 1 power dx. So now notice that this negative 1 can be extracted out and we can assume convergence and interchange the infinite sum and the infinite this integral. So now we have the sum from k equals 1 to infinity of, we can take all the things that don't depend on x outside. So negative 1 to the k plus 1, we just extracted a negative 1 from here and nothing else. So we have just the integral from 0 to 1 of natural log of x, but the whole thing squared, times x to the, now using properties of exponents, we can write this is 2k minus 2 power dx. So until now we got this as our I. Now let's just make a slight modification here. We have this sum from k equals 1 to infinity of minus 1 to the k minus 1, and the integral from, it's not infinity, sorry, it's 0 to 1, my bad, integral from 0 to 1 of natural log of x whole thing squared times, now I want to write this as x to the 2k minus 1 dx, because now I can write this as the sum from k equals 1 to infinity of minus 1 to the k minus 1, and the integral from 0 to 1 of natural log of x whole thing squared times x to the 2k minus 1, and then we can bring this other x to the negative 1 in the denominator like this, and dx. Now notice that the derivative of the natural log 1 over x is just present in the integrand, so we could do a really fruitful substitution of, say, letting u equal natural log of x. Well, not exactly entirely u equals natural log, let's say negative u, and I'll explain to you why negative. So now when you take the derivative, you have du equals negative 1 over x dx. So I now becomes sum from k equals 1 to infinity of minus 1 to the k minus 1, and now when x tends to 0, the natural log of 0 will tend to negative infinity, and having a negative over here will cancel the negatives between them, so we just have infinity. When x is 1, natural log of 1 is 0, so we have something like this, and instead of the natural log we have negative u, but that squared will just be u squared, because negative 1 squared is just 1. And now x, what is x? So e raised to negative u is x. So let's make that substitution, e raised to negative u to the 2k minus 1 power, and well, dx over x is just present over here, right, because of the denominator x. We just have this extra negative sign associated with this, and a du. So well, we can suck up the negative and then flip the upper and lower bounds. So now we have the sum k equals 1 to infinity of minus 1 to the k minus 1, and the integrals now from 0 to infinity of u squared and e to the negative u times k minus 1 du. Well, this almost looks like the gamma function, right? Except we have this other coefficient that, you know, it's basically a constant with respect to u along with it. So we want to get rid of it in any way. So what we do is we introduce another substitution. Let w equal to u times 2k minus 1, such that dw is equal to just 2k minus 1 du. So we are going to have sum from k equals 1 to infinity of minus 1 to the k minus 1, and then upper and lower bounds fortunately remain the same, otherwise reorganizing the gamma function would have been really hard. U is w over 2k minus 1, but everything is squared, and we have e raised to negative w, and du is nothing but dw over this factor of 2k minus 1. So now the 2k minus 1 terms can be taken outside the integral because they don't depend on w. So we have sum from k equals 1 to infinity of minus 1 to the k minus 1 divided by, well, we have a square here and we have one other term here, so that becomes a cube. So 2k minus 1 cubed and the sum from 0 to infinity of w squared times e raised to negative w dw. And if you recall the definition of the gamma function, this is just whatever the power of w is plus 1, the gamma of whatever the power of the w is plus 1. So 2 plus 1, gamma of 3. So we just obtain the gamma function of 3 times this crazy infinite series from k equals 1 to infinity of minus 1 to the k minus 1 divided by 2k minus 1, the whole thing cubed. So we have to consider now this infinite series, which by just shuffling the indices a little bit, we have sum from k equals 0 to infinity of minus 1 to the k divided by 2k plus 1, the whole thing cubed. And now this is a well-known standard result, because now notice this is almost the Catalan's constant, except there is no square. If we had a squared term in the denominator, this would definitely be the Catalan's constant, and that would be the end of our troubles. But we have a cubed here. So unlike the Catalan's constant, whose transcendentality and irrationality was unknown, this series converges to a nice value of pi cubed over 32. And I'm going to make a separate video on proving how this infinite series is pi cubed over 32. But let's just stick with this value now. So after considering the series separately, we have I now equal to gamma of 3 times pi cubed over 32, and the gamma of 3 is basically 2 factorial. 2 factorial is 2, so 2 times pi cubed over 32, and cancelling out some common factors, we have pi cubed over 16 as the final answer here. Isn't that really nice? I mean, the pi just comes out of nowhere again, and we didn't even have any trigonometric or inverse trigonometric terms. We just had a natural log and a normal quadratic denominator. So to sum everything up quickly, we had the integral I defined as integral from 0 to 1 of natural log of x, the whole thing squared, divided by 1 plus x squared dx. We used the concept of converting this denominator back into a geometric series, and then basically just playing along with identical resembling forms of functions like the gamma function, and then we obtained a really weird series of basically alternating odd cube terms in the denominator, and finally we came to a nice answer of pi cubed over 16. So you can also write this series as inverse of odd terms cubed alternating. So when k is 0, we have 1 cubed minus 1 over 3 cubed plus 1 over 5 cubed minus 1 over 7 cubed, vice versa. That just comes to pi cubed over 32. That's just one insight. But don't worry, I'll be making an entire video on calculating this. I hope you enjoyed this video, guys. Please like, share and subscribe to my channel. Please recommend me to all your friends, fellow mathematicians, physicists, scientists, anybody you know. I just really want to grow, and that will really encourage me as a YouTube video creator. And you can also follow me on Instagram. I have this account name. And in the meantime, stay home, stay safe, have a great day, peace out.